All right, this is a demonstration of Natter. To kind of go over what Natter is again, Natter is NAT over relay. And this is in NAT mode. This is what it looks like in Amazon. Basically, I have my client agent running right now, which is the Natter client. There's the Natter server, which is the egress side. That's how that's where the packets are egressing, and that's what the server sees. They see the IP address from the NAT server. This is why it's called NAT, because basically it's as if it was like NAT, and it's more of a distributed NAT. I can place this server in any location that we want. It's going through the relay infrastructure. So we are sending packets to the relays, and from the relays, it's sending packets to subscribers, and that's the egress side right now. And it works bidirectionally. So packets forward in a bidirectional fashion, both for UDP and TCP. So any UDP, any TCP. When I say any TCP, that's like TLS included, as well as UDP that includes QUIC or any other protocol that uses UDP. This all transparently goes through the relay infrastructure and can benefit from the relay infrastructure. So what I'm showing right now, or what I'm going to demonstrate here, is I'm in my Webex client. You're seeing me right now talking, and I am using my Desk Pro, and I'm using my Apple M2 to present. So content sharing is from my Apple M2, and one of my video streams is from my Apple M2 device. The other one is from my Desk Pro. And it's going through the standard Webex client. No changes to Webex at all. What we're kind of looking at here is this is the client mode. This is just some output of what it looks like with the client. There's a lot of tracking that needs to take place in order to keep flows flowing to the right destinations and keeping track of flows end to end. So what we're looking at here is a lot of that happening. And we also have the same thing on the server side. So we can look at all the flows and all the information about new flows being established, flows being torn down, both UDP and both TCP, to facilitate this call, including the content sharing and controls and everything else that's happening within the Webex client. We can see the server side. So this is the LAPS relay is running here, and we can see that it's very little. I'm only doing one call right now through this, but it's not too much CPU being used. And we can see the LAPS relay is using, around 4 or so %. The Natter server process is using anywhere between 2 to 5% CPU, but it's pretty basic and pretty simple. And some of the reasons why there's a little extra overhead with this is there's some additional logging and tracking that's being done that is just adding a little extra to the CPU usage. We can see the packet rates on the right-hand side here in this window. It is showing, like my total bytes coming in, out, as well as packet rates. And we can see the total kilobits per second rates as well. So we can see that it's an HD quality stream. My statistics right now, I'm going to take a screenshot and I will stop this share and I'll do a screenshot of my statistics to kind of show what this looks like. Actually, I'll go ahead and try to share my whole screen. To see if we can see if I can show the client statistics with my screen. So let's do content share, full screen. Okay, so if I want to look at the Webex statistics, it's in diagnostics. And we can see I'm connecting to Webex using UDP 5004. And we can see this is the audio. So packet loss is 0, which is really good. And latency is 50 milliseconds. This is going to Oregon, and I'm in Seattle location. The media server is located in San Jose. And we can see our jitter here, and we can look at the video as well, and we can see what the video is showing. My video is minimized right now, which is why it's a little bit lower on this, but we can see that the rate right now is 0% packet loss, latency is 50 milliseconds, jitter 17 milliseconds. So it's running pretty stable with very little latency and problems with it. And we can also see a content sharing. So as soon as I stop the content share, my video quality will jump up. But right now, because I'm doing the content share, it's not. Let's see. So we can see this is what we're sending with the content share. It's also using UDP, this destination. Now, one interesting thing to show here, and also the proof that we're really going through the NAT over relay, is if you click on this view details, you can see the round trip times. You can see what the media server is reporting back, which is basically its thumb probe that obtains this information. And we can see the call information here. The media server that I'm going to, we can see that I succeeded, and we can see the IP address. This IP address is an Amazon IP address. So this is the Natter server IP. It is not my Comcast IP address. And this is what the server sees. So the server thinks it's talking directly to me. And what's kind of interesting also is that we don't support trace routes or tracing through the Natter program. So it kind of gets a false trace route because that doesn't actually work through this, but it only shows like one hop through this as well because it technically doesn't work because ICMP is not supported, at least right now. So time exceed messages won't come back is what's the reason why this doesn't really show the trace routes. If you were to look at this outside of Natter, you would have a hop list because the time exceed messages actually come back. So that's why I would show that. That's basically it. And let me go ahead and stop this. This will, once I stop sharing, it'll jump up the video quality again and go back to a larger size. We can see that it's working pretty well. And that's basically it. So more to come with this.